hydrogen bonding can be so confusing. So I want to talk about some of the common mistakes people make so you won't ever make them. Okay, so hydrogen bonds are a type of intermolecular bond. And intermolecular bonds form between molecules. That's why we call them intermolecular. Now this between part is super important. Between two different molecules. I'm underlining it twice in red. Okay, let's look at hydrogen bonds in some ethanol molecules. So, ethanol is an alcohol, and if we could take a drop of ethanol and zoom in zillions and zillions of times in it, this is what we'd see. We'd see a bunch of different molecules all twisting around into different orientations, and here they are. So, where are the hydrogen bonds in these molecules? Well, as I said earlier, intermolecular bonds, hydrogen bonds, form between molecules, okay? So, this can't be a hydrogen bond because it's not between molecules, okay? The CH, that can't be a hydrogen bond either because it's in the same molecule. It's not between molecules. And the CC, it can't be a hydrogen bond either because it's in the same molecule, not between different molecules. Okay, so that's the first important thing to keep in mind. If a bond isn't just one molecule, it's not an intermolecular bond, and it's certainly not a hydrogen bond. Okay, so that means that the hydrogen bond has to be between different molecules. Here's how it works. In hydrogen bonding, an H, in this case, an H connected to an O is bonded to an O on another molecule. Okay, so this H is attached to an O, and so it will form a hydrogen bond with this O over here. I'll indicate this hydrogen bond with a couple red dots. Okay, so there's a hydrogen bond here. This H connected to the O here can form a hydrogen bond with this O over here on this other molecule. So again, a hydrogen bond I'll indicate with a couple of these red dots. So there's a hydrogen bond here. Okay. Now, a common mistake that some people make is they think any time there's an H, it can form a hydrogen bond between molecules. Okay, so they say, oh, there's an H here connected to the C, there's an H here connected to the C. So this can form a hydrogen bond, right? No, it can't. It has to be an H that's connected to an O, bonding with another O in this case. So it can't be this H with a C and this H with a C. That's not a hydrogen bond. Another mistake is taking an H that's connected with a C and connecting it with an O. Okay, that's kind of half right because in this case O's are forming hydrogen bonds, but if the H is connected with a C, it cannot form a hydrogen bond either. It's got to be an H connected with an O, making a bond with an O on another molecule. This is wrong, but these two hydrogen bonds between the molecules, this is the way to go. Okay, so now that you know how to find and draw hydrogen bonds, let's talk about how hydrogen bonds form in the first place. Okay, here I have two ethanol molecules. They're going to form a hydrogen bond between them. Okay, in this case, it's all about the O and the H. Okay, so the O and the H in this molecule are connected to each other with this line, which indicates that it's a covalent bond that's holding them together. They're sharing electrons to form this covalent bond. So they're stuck together because they're sharing electrons. Here's the thing though with the sharing. They are not sharing those electrons equally, okay? The oxygen has what we call a higher electronegativity. All that means is that when it shares with hydrogen, it hogs the electrons, okay? So it's maybe supposed to be sharing equally, but instead it's hogging the electrons. Because it has all of these extra electrons that it's hogging, it has a little bit of a minus charge, okay, because of those electrons that are spending more time with it. So we can write this minus sign here in this squiggle that's actually a lowercase Greek delta letter D. Oh, it is a lowercase Greek letter delta. Okay, that's what I meant to say. Okay, so anyway, we have this lowercase Greek delta with a negative sign, meaning that O is a little bit negative because it's hogging those electrons. On the other hand, hydrogen here is getting the electrons hogged away from it. So it's missing those electrons, so it has a lowercase delta plus. It's a little bit positive, okay? Now the same thing is happening over on this molecule. The oxygen is hogging electrons, so it has a delta minus sign because it has a little bit of a negative charge, those extra electrons that it's hogging away. And the H, which is getting thieved away from here, it has a little bit of a positive charge. So now you can see what's going on here is that the positive hydrogen here is going to be attracted to the negative oxygen here. So this attraction, it's sort of like magnets. You know how magnets attract together? It's like this attractive force between the positive hydrogen and the negative oxygen. So we can say that the hydrogen bonds are formed because O is hogging electrons from H. It's making O a little bit negative, it makes H a little bit positive, so this positive H is going to be attracted to a negative O on another molecule. Now here's the thing. Earlier, I said that if an H is bonded to a C, it will not form a hydrogen bond. Here's why. It's because C and H share their electrons evenly in this bond. Because they're sharing them evenly, it's not possible for the C to become negative and the H to become positive because the electrons are spending equal time with both of them. So you don't get these negative and positive charges when an H is bonded to a C. Since there are no charges, H's bonded to C's can't form hydrogen bonds. Okay? So, it turns out that O and H aren't the only atoms that can form hydrogen bonds. Okay? We saw just a minute ago that O, when it's bonded to H, O hogs those electrons away from H. It's not the only atom that can do that. Fluorine also has a high electronegativity, which means it likes to hog. So fluorine, when it's bonded to an H, also has a little bit of a negative charge, making the hydrogen get a little bit of a positive charge. Nitrogen, too, is able to hog electrons away from hydrogen, so it gets a negative charge, giving hydrogen a positive charge. So, there are three atoms that can participate in hydrogen bonding besides a hydrogen, and they are F, O, and N. If a hydrogen is bonded to an F, an O, or an N, that hydrogen can form a hydrogen bond. You can think about it because it spells phone. I mean, not spelled correctly, but it's like F-O-N, phone. So here's the thing. These guys all have to attach, they have to be attracted to an atom on another molecule. Okay, so for example, this positive H here can be attracted to an O on another molecule because that O will be a little bit negative. But this O could also bind with an H attached to an F. Or the O, because it's a little bit negative, could bond to an H that's attached to an N. Okay, so that's possible. Or you could have an F, a fluorine, bonding with any of these H's. If the H is attached to an F or an O or an N, this slightly negative fluorine will be able to bond, to hydrogen bond with a positive hydrogen. Okay? And similarly, nitrogen too, when it's on another molecule, can form a hydrogen bond with any of these three combinations. The H to the N, the H connected to the O, or the H connected to the F. So, whenever you see a hydrogen connected to a fluorine, an oxygen, or a nitrogen, that means that it can form a hydrogen bond. Any of the hydrogen can form a hydrogen bond with a nitrogen, a fluorine, or an oxygen on another molecule. So that is hydrogen bonding.